When using a transformer configured with a 100% concentric neutral XLP primary cable, a neutral connection on the secondary side of the transformer is typically not needed. A 100% concentric neutral cable features a neutral conductor that matches the size of the phase conductors. This design creates a low impedance path for fault currents, effectively minimizing the neutral current to practically zero. The X0 conductor, serving as the neutral conductor on the primary side, must be grounded at the transformer to ensure proper grounding. A number 6 American wire gauge conductor is usually adequate for this grounding purpose. Since the secondary side does not require a neutral connection, a 3-wire cable will suffice to connect the transformer to the load. Therefore, when employing a 100% concentric neutral XLP primary cable, configure the transformer as Delta-Wye and use the 3-wire cable for the secondary connection. Make sure to ground the X0 conductor on the primary side using a number 6 American wire gauge conductor. The fact that you have a 100% concentric neutral cable means that the neutral conductor is the same size as the phase conductors. This provides a low impedance path for fault currents and reduces the neutral current effectively to zero. When a transformer is configured this way using a 100% concentric neutral primary cable, the neutral current on the secondary side becomes negligible. This is why a neutral connection on the secondary is not typically necessary. Instead, the X0 conductor, which is the neutral conductor on the primary side, should be grounded at the transformer to maintain proper grounding. A number 6 American wire gauge conductor is usually sufficient for this. Given that a neutral connection is not required on the secondary, a 3-wire cable is typically acceptable for connecting the transformer to the load. To summarize, with a 100% concentric neutral XLP primary cable, the transformer should be set up as Delta-Wye, connected with a 3-wire cable on the secondary. Ground the X0 conductor on the primary side using a number 6 American wire gauge conductor. Remember to verify that the transformer is appropriately sized and adequately protected for the load it will serve. It is also crucial to adhere to all local electrical codes and regulations during any electrical work. This setup leverages the benefits of the 100% concentric neutral cable to minimize neutral currents and simplify the secondary wiring. Always prioritize safety and compliance with relevant standards during installation and maintenance. When dealing with electrical systems, understanding the specific requirements and characteristics of each component is essential for ensuring reliable and safe operation. A 100% concentric neutral cable helps balance the current distribution and reduce the potential for voltage imbalances, which is particularly important in 3-phase power systems. The Delta-Wye configuration further enhances the system's stability and performance. By grounding the X0 conductor properly, you establish a reference point that helps protect against overvoltages and fault conditions. This grounding practice is a fundamental aspect of electrical safety and should never be overlooked. Furthermore, the use of a 3-wire cable on the secondary side simplifies the wiring process and reduces the overall cost of the installation. This approach is particularly suitable for applications where the load does not require a neutral connection. However, always ensure that the load is compatible with this configuration before proceeding. To ensure proper operation and safety, it is imperative to follow the manufacturer's recommendations and industry best practices. Regular inspections and maintenance can help identify and address any potential issues before they escalate into major problems. It's also a good practice to keep detailed records of all installations, modifications, and repairs performed on the electrical system. This information can be invaluable for troubleshooting and future maintenance activities. In addition, consider the environmental conditions in which the transformer will be operating. Factors such as temperature, humidity, and exposure to corrosive elements can affect the performance and lifespan of the equipment. Implement appropriate measures to protect the transformer from these factors, such as using a weatherproof enclosure or applying protective coatings. By taking a proactive approach to electrical system management, you can ensure reliable power distribution, minimize downtime, and enhance safety for personnel and equipment. Always prioritize safety and adhere to relevant codes and standards to prevent accidents and ensure compliance. Remember that electrical work should only be performed by qualified and experienced professionals who are familiar with the specific requirements of the installation. Improperly installed or maintained electrical systems can pose serious risks, including electrical shock, fire, and equipment damage. Therefore, it's essential to seek expert advice and assistance whenever necessary. By staying informed and following best practices, you can ensure the safe and efficient operation of your electrical system for years to come. Branding is crucial to electrical safety. Branding the X0 conductor on the primary side with a number 6 American wire gauge conductor is vital. This establishes a low impedance path for fault currents, providing a return path for these currents to the source, and thus tripping the overcurrent protective device like a circuit breaker or fuse. The size of the grounding conductor is crucial. Number 6 American wire gauge is often sufficient, but always consult local codes and regulations for specific requirements. Branding ensures that non-current carrying metal parts of the equipment are at or near ground potential, minimizing the risk of electric shock. This includes the transformer enclosure, conduit, and other metallic components. The ground connection should be reliable and permanent, resistant to corrosion and mechanical damage. Regular inspections of the grounding system are recommended to ensure its integrity. The Delta-Wye transformer configuration offers several advantages. A delta-connected primary winding provides a path for third harmonic currents, reducing voltage distortion. The Y-connected secondary winding provides a stable neutral point which can be grounded to provide a reference for single-phase loads. This configuration is commonly used for distributing power to commercial and industrial facilities. The absence of a neutral on the secondary side simplifies wiring and reduces the number of conductors required. However, it's important to ensure that the load is balanced to prevent excessive current flow in any one phase. Unbalanced loads can lead to voltage imbalances and overheating of the transformer. Proper load balancing is essential for efficient and reliable operation. Consider the load characteristics when selecting a transformer. The transformer's kilovolt-ampere rating should be sufficient to handle the maximum expected load, with some margin for future growth. The transformer's impedance should be appropriate for the application, balancing voltage regulation and fault current levels. Consult with a qualified electrical engineer to ensure proper transformer selection. Regular maintenance is essential for extending the lifespan of the transformer. This includes periodic inspections, cleaning, and testing. Check for signs of oil leaks, overheating, corrosion, and other damage. Perform insulation resistance tests to assess the condition of the windings. Replace any damaged or worn components promptly. A well-maintained transformer will provide years of reliable service. Safety is paramount when working with electrical equipment. Always de-energize the equipment before performing any maintenance or repairs. Use appropriate personal protective equipment, including gloves, safety glasses, and insulated tools. Follow lockout-tagout procedures to prevent accidental energization. Work with a qualified electrician who is familiar with the equipment and safety procedures. Electrical safety should never be compromised. Understanding the specific application is important. For example, the location of the transformer, environmental conditions, and the type of load being served. Pad-mounted transformers are typically installed outdoors and are designed to withstand harsh weather conditions. They are commonly used for distributing power to residential and commercial areas. The transformer should be installed on a level concrete pad to provide a stable and secure foundation. Proper ventilation is essential to prevent overheating. The surrounding areas should be kept clear of obstructions. The transformer should be protected from physical damage, such as vehicle impact. Consider the long-term reliability of the transformer. Select a transformer from a reputable manufacturer with a proven track record. Consider the availability of spare parts and service support. A reliable transformer will minimize downtime and reduce maintenance costs. The 100% concentric neutral XLP cable plays a critical role. The concentric neutral provides a low impedance path for ground fault currents, enhancing safety. The XLP insulation provides excellent electrical properties and resistance to moisture and chemicals. The cable should be installed in accordance with the manufacturer's recommendations and all applicable codes and regulations. Proper cable termination is essential to ensure a reliable connection. Use appropriate connectors and tools. Follow the manufacturer's instructions carefully. Inspect the cable regularly for signs of damage. Replace any damaged cable promptly. Proper cable management is essential for preventing damage and ensuring long-term reliability. Ensure the cable is properly supported and protected from physical stress. Avoid sharp bends and kinks. Use cable trays or conduits to protect the cable from damage. Proper cable management will extend the lifespan of the cable and reduce maintenance costs. Always prioritize safety and follow best practices. Regular inspections and maintenance can help identify and address any potential issues. Electrical work should only be performed by qualified and experienced professionals. Stay informed about the latest codes and regulations. By following these guidelines, you can ensure the safe and reliable operation of your electrical system. The selection of the correct transformer depends on several factors. The voltage levels, kilovolt ampere rating, impedance, and winding configuration must all be carefully considered. Consult with a qualified electrical engineer to ensure that the transformer is properly sized and selected for the application. The installation of the transformer must be performed in accordance with all applicable codes and regulations. This includes proper grounding, bonding, and overcurrent protection. A qualified electrician should perform the installation to ensure that it is done safely and correctly. The maintenance of the transformer is essential for ensuring its long-term reliability. Regular inspections, cleaning, and testing should be performed to identify and address any potential issues. A well-maintained transformer will provide years of reliable service. The use of a 100% concentric neutral XLP cable is a key factor. This type of cable provides a low impedance path for ground fault currents, enhancing safety. The XLP insulation provides excellent electrical properties and resistance to moisture and chemicals. Proper cable installation and termination are essential for ensuring a reliable connection. The 3-wire secondary configuration simplifies wiring and reduces the number of conductors required. However, it's important to ensure that the load is balanced to prevent excessive current flow in any one phase. Proper load balancing is essential for efficient and reliable operation. The grounding of the X0 conductor on the primary side is crucial for electrical safety. This establishes a low impedance path for ground fault currents, providing a return path for these currents to the source, and thus stripping the overcurrent protective device. The size of the grounding conductor is crucial and should be determined based on applicable codes and regulations. Overall, the proper selection, installation, and maintenance of the transformer and associated equipment are essential for ensuring a safe and reliable electrical system. Always prioritize safety and follow best practices. Ensure that the transformer is properly sized and protected. This includes selecting the correct kilovolt ampere rating, voltage levels, and overcurrent protection devices. The transformer should be installed in a well-ventilated area to prevent overheating. The surrounding area should be kept clear of obstructions. The transformer should be protected from physical damage, such as vehicle impacts. Regular inspections and maintenance are essential for extending the lifespan of the transformer. This includes periodic inspections, cleaning, and testing. Check for signs of oil leaks, overheating, corrosion, and other damage. Perform insulation resistance tests to assess the condition of the windings. Replace any damaged or worn components promptly. A well-maintained transformer will provide years of reliable service. Safety is paramount when working with electrical equipment. Always de-energize the equipment before performing any maintenance or repairs. Use appropriate personal protective equipment, including gloves, safety glasses, and insulated tools. Follow lockout-tagout procedures to prevent accidental energization. Work with a qualified electrician who is familiar with the equipment and safety procedures. Electrical safety should never be compromised. The 100% concentric neutral design is advantageous. The concentric neutral provides a low impedance path for ground fault currents, enhancing safety. The close proximity of the neutral conductor to the phase conductors helps to reduce voltage drop and improve voltage regulation. The concentric neutral also provides shielding, reducing electromagnetic interference. This type of cable is commonly used for underground distribution systems. Proper cable installation and termination are essential for ensuring a reliable connection. Use appropriate connectors and tools. Follow the manufacturer's instructions carefully. Inspect the cable regularly for signs of damage. Replace any damaged cable promptly. Proper cable management is essential for preventing damage and ensuring long-term reliability. Ensure the cable is properly supported and protected from physical stress. Avoid sharp bends and kinks. Use cable trays or conduits to protect the cable from damage. Proper cable management will extend the lifespan of the cable and reduce maintenance costs. Always consult with a qualified electrical engineer to ensure that the transformer and associated equipment are properly selected and installed. The electrical system should be designed to meet the specific needs of the load being served. The system should be designed to operate safely and reliably. The system should be designed to be energy efficient. Regular monitoring and maintenance are essential for ensuring the long-term performance of the electrical system. By following these guidelines, you can ensure the safe and reliable operation of your electrical system for years to come. A Delta-Wye transformer with a 100% concentric neutral primary cable is a sophisticated electrical component, and its proper implementation depends on a thorough understanding of electrical principles, safety regulations, and best practices. The X0 conductor on the primary side should be grounded with a number 6 American wire gauge conductor. Also, it is critical to follow all local codes and regulations for any electrical installation.